Last year I replaced the thermal paste on my GPU with this Thermal Grizzly PhaseSheet PTM, which is a phase change thermal pad. One of the supposed advantages of these thermal pads over thermal paste is better longevity. So now that it's been a little over a year, it's time to check in to see if it still performs as well as it did originally. Additionally, I'm also going to test PhaseSheet on the CPU against normal thermal paste, so that by the end of this video I can give my final recommendation about whether or not this is actually a good product. If you haven't seen my original video about this, I would recommend it, especially if you're thinking about repasting your GPU. But the short version is that my RTX 2080 had very high temperatures, especially hotspot temperatures, which meant that it had severe thermal throttling. This was completely fixed by changing to PhaseSheet, so I got both lower temperatures, less noise and better performance. I was of course very happy about this, but that doesn't matter if the performance will just degrade again over time. So let's jump directly into the test results. In ThermArc we see that the temperatures are about 1 degree higher now than 1 year ago. And this is also true for the hotspot temperature. This obviously isn't the best result, but I also believe that this is within margin of error because of small variations in ambient temperature or maybe fan speed. And if we look at VRM temperatures, these are about 2 degrees higher, meaning that the higher temperatures probably aren't the fault of the phase sheet, but rather something that affects the entire heatsink. Now, if we take a look at power consumption and clock speed to see if there's any thermal throttling, we can see that it's almost the same as 1 year ago, with maybe slightly lower clock speed. But all of the results we have seen so far are still far better than with the stock thermal paste. So overall, I would call this a pass for Thermal Grizzly. Now, my original test also had some more performance-oriented tests too, in 3D Mark and F124. But something has changed so that my card performs differently now. And I'm not sure if it's because of drivers or Windows or something else. But I have decided not to include those tests here because I don't know how representative they are. What I will show is the difference between the average GPU temperature and the hotspot temperature across all of my tests. This is important because I believe the main reason the original thermal paste performed so poorly is because it simply didn't cover the entire GPU die well enough, leading to some parts being way hotter than others. This is probably due to the so-called pump out effect. Now, I'm not going to sit here and pretend to be an expert on this, but as far as I understand it, this is especially a problem on coolers mounted directly on a silicon die, such as a GPU, since silicon and copper have different thermal expansion properties. So, over many repeated heating and cooling cycles, thermal paste can be gradually pumped out from under the cooler, which is obviously not optimal. Apparently, phase change thermal pads are much better in this regard because they are solid at room temperature, so they resist this pumping better. And based on my results, this seems to be true, because the temperature delta to the hotspot is basically exactly the same across all of my tests, leading me to believe that the phase sheet has just as good coverage of the die today as it had a year ago. Okay, so now we know that Thermal Grizzly PhaseSheet PTM at least has some pretty good longevity. And we also know from last time that it performs well on GPUs. What we don't know yet is how it performs on CPUs and how it compares against new thermal paste. So for this video I decided to also change the thermal paste of my CPU. It's an Intel i7 9700K cooled by a Be Quiet Dark Rock 4 using the original supplied Be Quiet thermal paste that is now about 7 years old. First, I changed it out for some Noctua NT-H1 that I had lying around, as one does. And then after that, I changed it out for some Thermal Grizzly PhaseSheet PTM. Before we begin, I think it's important to note two things. First of all, my CPU uses 95 watts, which is far less than GPU and also less than you'll find on newer flagship CPUs. But it's still in line with many modern mid-range chips, even though the 9700K is quite old. The second thing is that I'm not sure whether my cooler, the Dark Rock 4, provides the 300 to 400 newtons of mounting pressure that Thermal Grizzly recommends. But I have no idea how I would test this, so I guess we'll just have to see how it goes. In Cinebench, the best result was surprisingly from the 7-year-old original Be Quiet thermal paste, closely followed by Noctua NC-H1. PhaseSheet PTM seemed to really struggle in this test, but that was also somewhat to be expected, since it hadn't completed the recommended 10 heat cycles above 60 degrees yet. In fact, I ran this test 10 times to see if there was any improvement, but there didn't really seem to be any major difference. My best guess as to why is that when the CPU is 60 degrees, the heat spreader, and therefore the thermal interface material sitting between it and the cooler, is not as hot as the CPU die itself, meaning that the phase sheet possibly didn't reach the 60 degrees required. Because of that, I ran the test again some time later after some real use where the CPU had definitely become much hotter than the 60 degrees required. And this time the phase sheet comes much closer to the thermal paste, although it still lags a little bit behind. I also did a test in Battlefield 6 to simulate something closer to real-life gaming scenario, and here the CPU only used about 70 watts compared to 95 in Cinebench, but I ran the fans at a lower speed, closer to what I would actually normally use myself, and there's of course a graphics card heating up the case. So this is a much more difficult scenario cooling-wise. Here the Noctua thermal paste takes a joint victory together with the phase sheet, easily outperforming the old Be Quiet thermal paste. I think this shows that phase sheet really excels at higher temperatures, which we also saw in my F1 24 test a year ago. For the CPU test, however, I still need to give the win to Noctua NC-H1, which performed very good in both Cinebench and Battlefield. But I still think the phase sheet came out ahead of the old Be Quiet thermal paste overall, thanks to the strong result in a real gaming scenario. I also have to say that I didn't feel like some of the other advantages of using a phase change thermal pad translated that well to a CPU, mainly the ease of application. On a bare die, I really like that perfect coverage is essentially guaranteed, but with a heat spreader that isn't really that big of an issue on a CPU, and I find that just squeezing out some thermal paste is easier than cutting a thermal pad to size and then carefully aligning it. And of course, there didn't seem to be any real longevity problem with the Be Quiet thermal paste on my CPU. This is not to say that that would be the case on all CPUs. Perhaps it's because both the heat spreader and the base of the Dark Rock 4 are made from copper, so the pump out effect isn't really an issue here. I'm not 100% sure, but I think what we can safely conclude is that phase change thermal pads, like Thermal Grizzly PhaseSheet PTM, aren't miracle products, and they aren't necessarily any better on CPUs than regular thermal paste. So, finally, the conclusion. Can I recommend Thermal Grizzly PhaseSheet PTM? Yes, I would say so. Especially if you're repasting a GPU, I can't see any reason not to go with it or a similar product. It performs well and seems to have a good longevity, at least so far. But for a CPU, I honestly wouldn't bother. It doesn't really seem to be any better than good thermal pastes, and if longevity isn't an issue, I don't see any clear advantages. It's still a good product, don't get me wrong, but the money is probably better spent somewhere else. Maybe on an extra fan if you're after better temperatures. Anyway, that concludes my review of Thermal Grizzly PhaseSheet PTM. Let me know in the comments if you have any experience with it, that would be interesting to see. And if you want something else to watch, maybe check out my video about how I upgraded the fans on my graphics cards to ones from Noctua. You can also subscribe if you don't want to miss my future videos. But that was it for this time. Thanks for watching, and I'll see you in the next one.